Let me share my screen so you can see the topic that we are going to discuss today. Yes, is my screen is visible to everyone? Hello? Hello? Okay. Okay. So let me start with the stuff that we have just left in the last lecture. Yes. So what we have discussed in the last lecture regarding the sonnet and the basic structure of the sonnet and what are the different kind of the layer wise kind of the classification is there and what are the different stuff which is going to be changed or that need to be changed in the sonnet architecture. Okay, so we have discussed with the basic four layer of the particular task in which there is a path, line, section, and the photonic layer we have. And one by one, we have discussed about that. What are this? All the layers will do the task, and we have get the idea about that. Whenever there is a device to device communication, you can say from one device to another device communication, or you can say the example like that from STS to regenerator or regenerator to head and rope multiplexer. So we can say one stuff is going to be happen common, like you can say it is always having a photonics layer which is going to be common in each and every one. Okay, we have also discussed about that what are the different tasks of the regenerator, like how regenerator is going to be work, what are the basic functionality of that, what is the importance of the head and rope multiplexer, why it is required. We have given the example of that also, and likewise we have discussed the overall structure or overall kind of the communication link which is ultimately going to be created in kind of the sonnet type of the architecture. We have also discussed about that multiplexer, which is depend on the wavelength division multiplexing principle, and what are the we can say different frame structure is going to be there with the each and every link. So we have discussed on the frame structure also, like what is a sonnet frames and how this STS1 and STS frame is going to be formed. And if there is a STS1 frame is there, which is a 90 by 9, and if that is increased from STS1 to STS3, so you have get idea that that 9 byte vertically not going to be changed, but rest of the horizontal portion is going to be expand. Okay, if it is STS3, so we can say whatever the STS1 frame is there, which is going to be multiplied by the 3 times in a horizontal manner, while vertical number of bytes is going to be remain same. We have also discussed that how this STS1 frame is going to be transmitted. It is going to be transmitted like from left to right and top to bottom, and such a 8,000 frames per second is going to be transmitted in a kind of the sonnet structure. We have also calculated that how the one frame data rate is going to be calculated. We can say this STS1 data rate is calculated by like 8,000 frames per second, while we can say there is a 9 we can say rows are there, 90 columns are there, so we can say 9 1 by 19 multiplied by each byte containing 8 bits. So we can say 51.840 Mbps is going to be a data rate for the one frame STS1 type of the communication. But if it is going to be STS3, so entire structure or entire frame structure is going to be multiplied by 3 horizontally. So we can say it is a 3 by 90 is going to be created, and that ultimately data rate is going to be multiplied by the 3 times over here. So these are the stuff we have discussed in the last lecture, that what is a frame rate and all stuff. Now we need to start discussing that overall kind of the inside of that particular frame structure. Okay, so in that frame structure, there are the specific part is there. Like you can say, overall, like first three kind of the column and 3 row. We can say left side there is a 3 corner, 3 row and 3 column. We can say 3 cross 3 matrix. This bytes is going to be considered as a section overhead, and kind of the rest of the six kind of the lines, that six box are there, in we can say in horizontally as well as vertically, it's going to be three times. So I can say like that, out of the 90 kind of the bytes, or we can say 90 octet, out of that, this is a first three column is going to be specified for the section and line overhead. Out of that, first three rows is going to be applied for the section, and rest of the six row is applied for the line. And you all know that what is a section, what is line, and what is a photonics. Okay, so there are the different stuff here. So from this one, you can directly identify that if I can say section overhead, if I can say line overhead. So from this previous diagram, you can go it over here. Okay, like it's a section overhead, it means whatever the number which is available in that section, or whatever the data available in that section, which is going to be changed at every regenerator. Okay, so whenever it is passing from any multiplexer to regenerator, so that section data might be going to be changed. But when the line kind of the data is going to be changed when it is entered to the add and drop multiplexer. So from this particular name, you can get the idea that whenever I can say section and line, so I can say this is going to be changed, might be changed, or it's going to be modified at the I can say at the regenerator level, while line, that data is going to be changed at the add and drop multiplexer level. Rest of the portion, it's 9 rows and 87 column, which is data, or we can say whatever the overhead is there and whatever the information is there, which is going to be situated in a 9 rows and 87 columns. So what are the inside of that first 3 cross 3, that yellow color portion? So there are several numbers are there, A1, B1, A2, C1 up to the D3. There are the different numbers there. So this number will give you the data that like it's kind of the frame alignment, what is the management beats are there, parity beats are there, parity beat that we can use for error detection. Okay, then order by wire beat, identification, users. Okay, so what are the basic information is there, like you can say what is the source, source identification is there, what is actually the message is containing, what is the frame alignment is there, whether it is starting from in between of that, or it's just beginning at the most first position. Likewise, I can say that basic fundamental beats and information which is situated in a first 3 cross 3 column. Okay, so section overhead is recalculated for each Sonet device, regenerator and multiplexer. So we can say whatever the section overhead is there, which is going to be recalculated at every stage, whether it is a regenerator or it's a multiplexer, this particular frame is going to be recalculated every time, okay, whenever it is entered from one device to another device. Rest of the line overhead are there, that we can say having a variation from H, B, D, Z, okay, K, and such type of the beat is there. So these are the parity byte also there. So we can say in the line overhead also parity beat, management beat, old wire beat, growth wire beat, then automatic protection switching, pointers. So depend upon that which type of the information is available in entire kind of the data. According to that, this a line overhead is going to be added over there. Sometimes you can say like whatever the frame you are sending, I can give you the example like that. If you are using a simple application, like you are using a web browser, or if you are using a such type of the file transfer, okay, if you are just multiplexing the more simultaneously 3 signal to that one, okay, so according to that that all the multiplexing signal type of the accessing information, this entire byte and this pointers and every stuff is going to be changed over there. Okay, after that also we are having a path overhead also we have, which is going to be just after the we can say over here we have discussed the stuff like the path overhead, like whatever the rest of the frames are there, 9 by 87, out of that there are one path overhead is also going to be there. We can say one type of the flag creator, like I am a path overhead, I can give you that this is a particular link or this is a particular stuff that I'm carrying with this one. So it is also containing a path label signal, status, that user channel byte, parity byte, growth byte, and several the different byte is going to be available over there. But we can say path overhead is only going to be calculated at the end to the end. So we can say whenever we are calculating kind of the line is there, section is there, photonic layer is going to be there. Okay. So likewise, this path overhead is only and only going to be recalculated at the end-to-end multiplexer. So what we have discussed, like in, we can say whatever the stuff we have over here, line overhead. Okay, we can say section overhead. So section overhead is going to be changed at the every regenerator and multiplexer, while we can say this line overhead is going to be changed at the add and drop multiplexer. But while we are having a path overhead, which is an end-to-end communication, it's related to the end-to-end communication, so it's going to be changed at the STS multiplexer. Okay. So in overhead byte, there are the different kind of the classification is there, like what are the byte functions are there? To alignment of the bit, giving the parity identifier. Okay, we can say A and M management bits are there, order bit are there, failure tolerance, trace, pointer status. Several type of the functions are there, which is going to be performed at the different layer. Like it's a section layer, it is up to the user, it is going to be performed by the different section, while in the line that pointers, failure tolerance, and growth is going to be applied. While in the path, like parity, identifier, user status, pointer, trace. So we can say depend upon that different byte function. Okay, that different type of the overhead byte is going to be added with that. We can see some of the common kind of the stuff over here, which is a parity. So we can say that parity is going to be applied in every section. Like we can say in every layer. I can say in section layer also parity byte is there, line also there, path also there. So we can say, you can take the example like that, whatever the combined frame is created. So whatever the combined frame which is going to be created in your system, so we can say with respect to that, you need to add the specific section line for that also, a parity bit for the section portion also, line portion also, and path portion also. Okay, आप ये भी कह सकते हो कि जो भी डेटा कलेक्ट हो रहा है उसका भी पेरिटी चेक कर रहा है, उसके बाद जो एडिटिव बीट ऐड होगा वो जो पूरा डेटा बनेगा उसका भी एक पेरिटी बीट है, और वो सब कंबाइन करके जब आप एंड थ्रो करते हो पूरा पैकेट पूरा फ्रेम, उसके लिए भी एक पेरिटी बनता है. Likewise, the different parity bytes is going to be added to identify the error, if it is error is there or not in your system. Now, if we can say, let's consider there are a frame is created, depend upon the line, path, and section, all this stuff. This that frame is created, but we can say it is a multiplex structure. Okay, like STS multiplexing, we can say like whenever we are having STS one signal, so such type of the single frame 90 by 9, such frame 8,000 times in second going to be sent it. But I can say if it is going to be a 3 STS3 frame, so meaning of that one, like in STS3, you are having a 3 frame is going to be transmitted simultaneously. And if it is going to be 12, so we can say such type of the 12 frame is going to be transmitted. But how it is going to be transmitted, what are the byte interleaving is there, what are the concatenated signal is there, if add and drop multiplexer is going to be added, and what are the different processes going to be happen with that one, that we need to discuss over here. So this is the simple representation, block representation we have. Like we can say STS3 STS frame we have, STS1 frame we have, and that is going to be multiplex over here and created a STS3 frame. As well as when this STS3 frame is going to be entered to the demarc structure, at that time this STS3 frame is going to be divided into the separate STS1, STS1, and STS1 over here. Okay, so these are the basic process is going to be happen. Now, what actually going to be happen at the frame level, that we need to discuss just after that. So in Sonet, all the clocks in the network are logged to the master clock. So what is the meaning of that? Like whatever the data is going to be exchanging between all this particular process, between regenerator, add and drop multiplexer, all this stuff, first thing we need to keep in mind that whatever the clock which is set at each and every position or at each and every place, which is going to be followed with a one master clock. Okay, so we can say all clock in the network are locked to the master clock. We can say all of them need to choose a one common clock between them, and according to that clock they need to take a decision. Okay, so clock is going to be common in everywhere, it's not going to be changed. We can say this is a synchronous type of the communication, while all the clock at each and every place going to be the same, which is in lock-in mode. So this is actually going to be happen in STS3 frame. You can see there are three different bytes there. You have seen like there is a we can say pink, yellow, pink, and blue type of the frame is there. So I can say it is going to be defined like this one. So what is going to be there? This is a byte interleaving is there. So initially we can say all the byte of the first station, then there is a second, then there is a third. After completing the portion of the first kind of the column from each and every one, now it is going to be interleaved with the second one. So then there is a second column of the first station, then second column of the second station, and second column of the third station will come. Likewise, third column from the first station, third column from the second station, and third column from the third station. Likewise, over here that byte is also going to be interlinked. You can take the example like that. All the stations are there, all the input station are there. We can say that input station is going to be a is bounded with the one clock. So we can say each and every station having one specific time period. You can say 1 second you have, just for example, that 1 microsecond you have given for the first station. So in which it will send their first entire this portion of the data. After that, that clock is going to jump. That multiplexing clock is going to be jumped to the second station. So second station will give the data. Then third station. Likewise, again it will come from 1 2 3 1 2 3 1 2 3. Likewise, this byte is going to be interlinked. It's nothing but is a one type of the time division multiplexing. But over here, byte interleaving is there, column by column. Okay. So likewise, there is a STS3 frame is generated, and that section overhead now it's increased to 9 byte because it's a 3 byte 3 frame are there. So previously it was 3 x 3 9. Now it's going to be 9 x 3 over here. As well as this line overhead also going to be increased, and entire frame is increased by 3 times. So this is a stuff we have, like whenever there is a STS3 frame is there, and we also need to add a path overhead from one station to the another station, like one STS multiplexer to another STS multiplexer. So overall there is a 10 octets are there. Okay, 9 for the section overhead, 1 for the path overhead, and rest of the 260 octets are there, which is nothing but the data which is set in a byte interleaving in manner for all the stations. Okay, is that 55 people be there? Okay. Yes. Now we need to see that if we are having a add and drop multiplexer is there. So what we have discussed in add and drop multiplexer, can anybody tell me? Or from this diagram also you can get the idea that what is add and drop multiplexer, what it will do. Can anybody revise this stuff? What is the task of add and drop multiplexer? Please open your mic and speak up. Anybody? Hello? If you are not giving the answer, then I need to go for the task like everybody go to the internet and find out that what add and drop multiplexer will do and type in the chat box. Chalo. Everybody go to the internet, identify that what is a add and drop multiplexer do. Okay, and type your response in chat box. You have a 5 minute to do that. Everybody start searching from the internet and type it in the chat box quickly. I have told you to identify that what actually add and drop multiplexer will do. Okay, it's important element of optical fiber. Obviously, that's why we have included in our optical fiber communication. It's an important element. But what actually that ADM will do? Okay, everybody write your answer quickly. So add and drop multiplexer is a critical element. Optical fiber, it combine several low bandwidth stream into the data in a single beam, and simultaneously it can drop and remove the low bandwidth signal from the stream of the data, direct them to the another network route. Okay. What about the other? Quickly, it can combine several low bandwidth into the single stream. Okay, that's on. A multiplexer combines or multiplex the several lower bandwidth stream into the data into the single beam of light. Okay, add-and-drop multiplexer also has a capability to add more lower signal. Dwarka says. So ADM is critical elements. The same answer. Okay, Dwarkesh. Quickly, in 2 minutes, 2 minutes. Any other person want to add anything? Does anybody can find out that if you want to do add and drop multiplexer? That's let me give you the question so you can get the better idea on that. If I want to do a add and drop multiplexer, okay, if you want to do add and drop multiplexer, then which type of the extra optical fiber device you require? Okay. Let me just share it over here also. Add and drop multiplexer. There are some lots of diagram available in the internet regarding the add and drop multiplexer and all type of the stuff. We will see some of the diagram of add and drop multiplexer over here and what it will do. Yes, is the screen is visible to everyone? This diagram?
Yes, sir.
Okay, so what is actually it's going to be do in a add and drop multiplexer? Just see over here that add and drop multiplexer is made up of these several elements, which is primarily like a circulator, isolator, and break grating structure are there. Okay, so what it will do in circulator, that how this add and drop is going to be actually created. So what is going to be do, like you need to give an input from one. Okay, listen carefully. You need to give an input from one, so that input is going to be one is directed to the port number two. Okay, it's like आप वन में इनपुट दोगे तो वो टू में जाएगा, आप टू में इनपुट दोगे तो वो थ्री में जाएगा, आप थ्री में इनपुट दोगे तो वन में जाएगा. Likewise, there is a circulator is there. Okay, so if you are giving input in one, it go to two. If you are giving input in two, it will go to three. If you are giving an input in three, it will go to the one. Likewise, there is a circulation of that data going to be created. Now consider that if you have given input into the one, so obviously it is going to be two as per the working principle of the circulator. Now at the particular port 2, what is going to be happen over here? It is extra circuit is going to be putted, extra optical circuit is going to be putted, which is name is a break grating. Now break grating is nothing but one type of the optical filter, you can say. So what optical filter will do, that whatever the period of this break grating filter, like it is designed for this stuff, like it is only allowed to pass some certain amount of the wavelength, and rest of the wavelength going to be rejected back. Okay, so you can say whatever the allow frequencies are there, allowed wavelength are there, which is going to pass through this break grating, and rest of the wavelength going to be coming to back. Now if it is coming to back, it means this is an input for the two. Okay, So you can say these are the input for the 2. So obviously as per the circulator operation, where it will go, if you have give the input from the 2, it will go to the output number 3. सो आप यहाँ पे ये कह सकते हो कि लेट्स कंसीडर यहाँ पे आपकी आपकी 3 वेवलेंथ थी, लैम्बडा 1, लैम्बडा 2, लैम्बडा 3, 3 सीक्वेंस थे 1 2 3. यहाँ पे आपने ब्रेक ग्रेटिंग ऐसा डिजाइन किया कि वो 1 और 3 को ही पास करने देगा और 2 को क्या कर देगा, रिजेक्ट कर देगा. सो व्हाट यू कैन अंडरस्टैंड फ्रॉम दिस वन. सो 2 तो 1 और 2 यहाँ से पास होके आगे चले जाएंगे, लेकिन 3 है वो यहाँ से फिर से वापस आएगा और जो भी वो signal number 3 going to be coming back from this grating, which is ultimately going to be reached to the port number 3, which is nothing but the drop frequency you can say, or drop wavelength. So यहाँ पे 3 भेजी थी लेकिन 2 आगे चली गई और 3 कहाँ पे मिल गई, port number 3 पे. Similarly, it is going to be happen at the port number 1. Okay, so what is going to be happen in the port number 1? You can say whatever the 2 frequency coming over here. Okay, whatever the 2 frequency coming over here, what you are going to do, that all this 2 frequency coming over here, तो आप 2 को पोर्ट नंबर 2 में वो आ रही है तो ऑब्वियसली वो 3 में चली जाएगी, लेकिन आपको 1 को भी यहाँ पे ऐड करना है. तो आप क्या करोगे, ये ग्रेटिंग स्ट्रक्चर आप ऐसा डिजाइन करोगे कि वो 1 को आगे नहीं जाने देगा इस साइड. ओके, दिस ग्रेटिंग स्ट्रक्चर नॉट अलाउड टू गो सिग्नल दिस साइड, और यहाँ पे नहीं जाएगा तो वो कहाँ पे जाएगा, वापिस 2 पोर्ट में से ही वापिस आएगा, एंड देन इट्स गोइंग टू बी एडेड विद द एक्चुअल सिग्नल व्हिच इज अ 1 and 2, एंड यहाँ पे नया एक सिग्नल ऐड हो जाएगा. सो likewise you can say if I'll go with this particular diagram again, so this is going to be happen. आप कंसीडर करो यहाँ पे कि आपका ये जो थर्ड नंबर का सिग्नल है that need to drop. So we can say over here in ADM there are the circulator, grating and such type of the structure is there, which is actually drop this packet. Particularly this packet is going to be drop over here, and whatever the new packet is there, which is going to be added at the place of this third one. Okay, so that dropping and adding of STS1 frame in the add and drop multiplexer, which is going to be happen like this particular process. Okay, anybody having any doubt, any question in this one? No doubt? Okay. Yes, Anurag, are you having a doubt, anything? Oh, okay. You have an acknowledgement for the voice. Okay. Now let me move for the next slide. Yes. So what is going to be happen in Sonet network? So as we know that, now we know that like add and drop is going to be happen. So what you can do, like simultaneously lots of signal are going to be travel in one particular ring, and from one particular station you can drop those signal, and that and it can make travel through the another ring, and from that also you can put another add and drop multiplexer, then it is going to be traveling to the side ring, and after that it's going to be reached to the final station. So you can say by applying the several type of the link and such type of the several type of the ring structure, what you can do, whatever the signal going to be passed through that link, and whatever the combination of all this frame, you can just drop it out from regional ring to the local ring, and from the local or metro ring to the side ring, and side ring to the one individual station over here. Okay, so we can say if some exchanging of the data is going to be happening in one particular big network, you can say just by putting this such type of the add and drop multiplexer, by putting the such type of the interconnecting devices, you can just take the actual data which is meant for you. So you can imagine like this stuff, like in India, you can say that there are one particular fiber link is there, fiber grid is there. Okay, lots of politicians and our prime minister has also just given this idea that whatever the highways are there, likewise there are a fiber highways are there. We can say there are a central fiber grid are there, which is going to be placed in each and every state, which is connecting the entire India. Okay, so we can say that data exchanging between state to state and kind of the region to region is going to be happen in that particular master, we can say that fiber kind of the highway. Okay, and whatever the data that you need to consume, okay, whatever the data which is made for the local region, तो आप ये सेपरेट पूरा एक हाईवे है, ये पूरा एक कनेक्टिंग चैनल है, आप उसमें से जो भी स्टेट के लिए जो भी डेटा चाहिए, सो जस्ट पुट द एड एंड ड्रॉप मल्टीप्लेक्सर, and you can just take the data for your particular site and for your regional level, and likewise you can take it, you can further modify it through your the regional location, like it once it will come to Ahmedabad, then it is going to be surrounded through entire kind of the Ahmedabad, Gandhinagar, Surat, in Rajkot, Kachpur. Like it's going to be create a ring in entire area. Like you can say there is a local ring. And when it is come to the Rajkot, so then Rajkot after there are one particular link network is there, ring network is there, through which the data is going to be said like this one. So whatever the data which is coming from the national highway, likewise there are a separate lanes are there. Okay, national highways are, we can say national highway, then regional highway, then kind of the local highway, then regular street. Likewise, this data going to be travel and it is reached to the one particular station. Okay, so this all stuff is going to be connected in ring in network, and likewise this entire Sonet network is going to be working over here. So this is all the stuff in this Sonet right now. Anybody having any question in this Sonet or not? Any question, any doubt? So if it is not, then I will move for the one new chapter. So just I will give the basic introduction on that one, and then after we will discuss that entire stuff in kind of the upcoming lecture over there. But anybody having any doubt in Sonet now? Okay, so let we will see that what is going to be a topic which actually going to be covered in data link control. So these are the somewhat, we can say there is a last topic of our syllabus. Okay, then after we'll go for the whatever the pending topics are there, or brief about that each and every topic, and this whole stuff we are going to discuss. But this data link control that we need to discuss very detailed manner, or you can say like that from this data link control onwards your computer network subject is going to be started. Okay, so whatever that physical layer and all stuff that we have discussed it right now after we are going to be do with the data link control. Okay, so what are the stuff which is going to be happen in the data link control, that it is basically started with the frame in a character oriented protocol. Okay, so whenever I can say that is a data link control, so it is first we will discuss with that how actually the frame is going to be created. Okay, so I can say frame in a character oriented protocol. What are the stuff we have? Like whatever the data which is coming from the upper layer, like we have discussed in our OSI layer that there are a layer wise layer data is coming, and each and every layer will add their own information. Just a second. So I can say like that whenever I'm having entire data which is coming from one layer, when it is reached to the another layer, that every layer will add their own information. Like it will add their header, it will add their trailer, it will add their flags are there. Okay, so by creating such type of the frame, which is very much important to identify the packet sequence. Okay, like you can say whenever this a flag is going to be changed, like ultimately we are sending a frames in our non-reliable network. Okay, like if you can go with the packet switching network, so you can get the idea that in a packet switching network what are the stuff actually going to be happen. In packet switch network, the stuff which is going to be happen, like each and every frame is going to be transmitted independently, and as per the traffic and scenario it is reached to the destination. So these are the stuff over here, like whenever we are having a flags and header and such type of the extra added kind of the data is there, which will ultimately use to distinguish between a two consecutive frame. Okay, तो आप ये समझोगे कि जब भी फ्लैग आता है तो आप समझोगे भाई बीट सीक्वेंस आना चालू हुआ है, you can say your data is started. Okay, and when the another flag came, you can say that one frame is ended. So likewise, frame starting, ending, all stuff you can identify by using flag and header and such type of the extra bits. So sometime it is going to be happen. Okay, sometime it is going to be happen that whatever the data that you have choose for this flag, ultimately this entire stuff is nothing but a beats. 1010 beats are there, or sequence of beats are there, you can say. So whatever the flag and header that you have choose, which is going to be constant, okay, which is going to be constant and which is going to be same for each and every frame. ओके, आप 50 फ्रेम भेज रहे हो, 500 फ्रेम भेज रहे हो, लेकिन ये फ्लैग और हेडर का जो सीक्वेंस है वो कभी चेंज नहीं होगा, which is going to be same. Okay, to and because of we need to distinguish between two consecutive frame. आपको सेम सीक्वेंस का पूरा एक सीक्वेंस मिले तभी आप पता कर पाओगे कि फ्रेम स्टार्ट हुआ, वही सेम सीक्वेंस आपका एंड में आएगा तब आप पता कर पाओगे ये एंड हुआ. तो जितने भी आप फ्रेम बना रहे हो वो डेटा यू नीड टू ऐड एज अ कांस्टेंट इन एवरी फ्रेम. So sometimes it is going to be happen like that. Whatever the data that you have chosen for this frame, or chosen for this flag or header, possible that same type of the data which is generated in the actual information. आपने लेट्स टेक यहाँ पे कंसीडर किया कि भाई मैं जब भी मेरा कोई बाइट है वो लेट्स टेक एट द रेट, लाइक वट एवर द आस्की कोड ऑफ द एट द रेट विच इज माई फ्लैग ओवर हियर. सो हो सकता है कि जो भी सिग्नल आ रहा है, जो भी एक्चुअल डेटा है, उसमें भी कहीं पे एट द रेट है. सो यू कैन से इट इज क्रिएटिंग अ कंफ्यूजन. ओके, whatever the flag sequence is there, whatever the flag character is there, that same character or same byte going to be repeated in actual data also. So to avoid that, two type of the stuff we have. What are the two type of the stuff? Which is a byte stuffing and beat stuffing. Okay. So in byte stuffing, we are considering that entire byte is going to be replaced with other, or some extra byte is going to be added. Okay. So let's take, there are some data which is coming, which is having itself having a flag type of the character is there, which is a common as a yellow over here. तो यहाँ पे जो फ्लैग का जो भी बाइट है वैसा सेम बाइट आपका डेटा में भी आ रहा है. तो अभी आप क्या करोगे, बिफोर कमिंग टू दैट फ्लैग यू आर एडिंग वन एस्केप कैरेक्टर. ओके, यू आर एडिंग वन एस्केप कैरेक्टर, and whenever such type of the listed escape is also going to be added in the header. So you can say if escape character is came, then you are adding a two extra escape character. So you can say whenever there is a flag or escape is going to be coming, which is a one of the identity of flag and header, you are adding one extra escape over there. ओके, तो आपका जो अल्गोरिथम होगा वो क्या कैलकुलेट कर रहा होगा कि भाई यहाँ पे फ्लैग आया और बाद में एस्केप है, मतलब कि जो भी नेक्स्ट बाइट है वो रिपीटेड है एज अ सेम फ्लैग, दैट विल गेट द आइडेंटिफायर एंड इट्स नॉट टर्मिनेटिंग द फ्रेम. वो ऐसा नहीं समझेगा कि भाई मेरा फ्रेम खत्म हो गया, अभी मैं दूसरा फ्रेम आइडेंटिफाई करूं. नो, frame is still on. Okay, there is a one extra escape character is coming, that's why I need to consider this is as a actual frame. Okay, ये actually अभी डेटा ही मैं प्रोसेस कर रहा हूँ, मेरा पूरा फ्रेम एंड नहीं हुआ है. Likewise, you can add the extra escape, and by applying the reverse algorithm, whenever there is a escape are there, you need to remove, that's considered as unstuff, so that extra byte is going to be added, removed from your actual sequence, and actual frame you can get at the end of the upper layer. So likewise, byte adding and byte removing, we can say byte stuffing and byte unstuffing type of the process is going to be happen to give a proper identity of the one particular frame. Okay, so byte stuffing is a process of adding one extra byte whenever there is a flag or escape character in the next. This is a simple definition I can say. What is a frame in a beat oriented protocol? Okay, so we can say, let's consider there is a flag is there which is made up of 0, 6 times 1s and again 0. Okay, so we can say over here there are data which is coming from the upper layer. Similarly, this flag is going to be added over here. So you can consider flag क्या होगा आपका constant 0, 6 times 1 0. So जब भी ये सीक्वेंस कोई डिटेक्टर डिटेक्ट करेगा आपके रिसीवर साइड, तो तुरंत आइडेंटिफाई करेगा भाई फ्रेम स्टार्ट हुआ, और वो एंड कब होगा, जब ये सेम सीक्वेंस उधर आए. Okay, so likewise you can say these are the frame is going to be identified over there. And with respect to that, there are a beat or protocol and this flag oriented protocol also going to be added, but that we are going to be discussing in next lecture, that what are the beat stuffing. We have discussed about the byte stuffing over here, but what are the beat stuffing, how it is going to be happen, and what are the algorithm for that, what are the data link protocol algorithm are there, that all stuff that we are going to be discussed in the next lecture. Now, what are the stuff as per the tradition? We are having 15 minutes approximately. You need to write a conclusion of the entire lecture in 8 to 10 lines, and at the end you need to write your attendance. Also, keep in mind that in last lab we have discussed this particular stuff. Whenever your next lab is came, be ready with your pending assignments. Whatever the pending assignments you have, be ready with that, and also prepare your mind to do the pending assignment in the next laboratory, because we are having a 2 buffer labs are there, in which whatever your pending task is going to be there, that we need to complete on that lab. As well as be ready with the stuff like in the next week, you will get a unit test 2 question paper. Okay, whatever the take-home test exam we have, okay, in the take-home test exam, the question paper which is going to be sent from my mail ID, and individual student get individual paper, and all the paper are going to be different. Okay, so if you have a 60 strength or 65 strength we have, so I have a 70 to 80 papers are there, so individual student can get an individual paper. So be ready with that. Unit test 2 is going to be concluded. It's going to be organized in next week, and we will give a 1 or 2 week of the time to complete that one. Okay. So everybody be ready with that one. And now it is time to write your response, that what you have learned from the entire lecture about the sonnet, about the byte stuffing. And at the end, you need to write your enrollment number. And then if you have any question, any doubt, you can ask me. Otherwise, you can just write your response and you can leave the class and wait for the next lecture if you have. Start writing, everybody. Yes, is there anyone in pending of writing the answer?
સર failed to send આવે છે.
You can send it to my WhatsApp. What is your number?
106.
106.
Yes sir.
સર મારું બી ફેલ ટુ સેન્ડ બતાવે છે.
Number. રોહનભાઈ કેમ તમે લેટ જોઈન થયા?
સર થોડુંક નેટવર્ક ઇશ્યુ હતું ને એટલે
એટલે છેલ્લે કેમ આવ્યા?
છેલ્લે સર એટલે આવ્યો કારણ કે નેટવર્ક ઇશ્યુ હતો સર.
એટલે છેલ્લે 10 મિનિટમાં થઈ ગયો નેટવર્ક ઇશ્યુ રિઝોલ્વ.
સર
નંબર બોલો.
જેટલું વેલ્યુ થયું IT32. સર IT32 32.
પાર્થ
યસ સર.
કેમ અત્યારે જોઈન થયા?
ના સર રિજોઈન કર્યું સર. આ મેસેજ ફેલ ટુ સેન્ડ આવતો હતો ને
ઓકે
વોટ્સએપ કરી દીધું તમને.
ઓકે.